Thank you. Thank you for the introduction. I'm going to speak about the indoor environmental quality, which is an input to the energy calculation. So we want to guarantee that the energy we are calculating for the different buildings will not sacrifice the indoor environment. And if we look at some of the costs that you have in a building, you clearly see that if you put the cost of people, here's the data for a typical office, then the energy cost is only 1% of that. So that clearly shows that buildings are for people and not really for saving energy. So what we have to make sure is that when we now do energy calculation, that we do not sacrifice the people part. The indoor environmental quality, as I said, is input parameters to these energy calculations. So they go, the criteria are used by several other standards. And we have one standard, EN15251, which is already existing. And that includes parameters for the design and also for the assessment of the energy performance of buildings. And when we talk about the indoor environment, we are here dealing with thermal comfort, thermal environment, the air quality, mostly related to ventilation, illumination, and acoustic. This new standard, or the revision of the existing standard, will be made so we will have a standard with basically normative text, but then it will be accompanied by a technical report. We'll give more guidance on how to use it. The criteria will be in the normative standard, but they will not be normative, the values itself. But the tables or how to express the criteria will be normative. So if countries are not going to use the default value that we will have in the standard, they can make a separate annex with their own values. An important new part of this standard will be a series of standardized occupant schedules, which has to be used in the energy calculations. Because if you change the schedules, you will change the final energy use of the building. So it's very important that we also here have some default values so people can do it in a standardized way. What's in 15251 is, of course, not all new. It's a revision of existing standard, and it's related very much to some other standards which are available international. One important thing is that we give in this standard, we are working with different categories, and we give the criteria for most of them at different levels. That means that countries can show, can select different levels for their default values. When we talk about the thermal environment, we have kind of two approaches. If we have buildings with mechanical heating and cooling systems, we use as a criteria for the thermal environment, one is an index for thermal environment, PMV, EPBD, or it could also be expressed the criteria as a range of operative temperature. But we will also have criteria for other comfort parameters like radiant temperature, symmetry, draft, vertical air temperature difference, and also floor surface temperature. These are especially important when you design your system. You have to make sure that you don't, that you are still within these criteria. So to get the different categories, we have here specified them in relation to the PMV index, where we normally recommend that what you should use is the category 2. But you could use other categories also. This can also be expressed as a range of operative temperatures. Here we have now for a special case, or the most typical case, that's office and spaces with mainly sedentary activity. So it could be conference rooms, auditorium, classrooms, restaurants. And then we are specifying the criteria for the heating season, winter, and for the cooling season. So using the range I showed before, for example, for a building in winter, you would need heating up to a minimum of 20 degrees. So that's normally for the design. You use the lower end of this interval. When we then go to cooling, the set point or the maximum value for the indoor operative temperature for summertime will then be 26. So that's how we deal with the thermal environment in mechanical heated and cooled building. Then there's studies that have shown that people's expectations, especially in natural ventilated buildings where there's no active cooling, can change, and they, in many cases, can accept a little higher temperature. So we have, for these type of buildings, in the standard we have specified when you can use this method. We have what we call the adapted approach, where you, based on the running mean outdoor temperature, it's basically a weekly mean temperature where you weigh the temperature the day before higher and then lower and lower, where people often, let's say, change their clothing and others depending on the outside temperature. So this gives then a range for this running mean outside temperature, and then you give a range here also for different category of operative temperatures which would be acceptable. So these are the two methods which will be involved when we talk about the thermal environment. Now, where we have the most discussion at the moment in revising the standard is related to the indoor air quality and how to get to numbers for what is a required ventilation rate. We have data showing what we know from many studies how much ventilation we need to dilute emissions from people. It's mainly bioeffluents. And also studies have shown that for health and other reasons you need a minimum of 4 liters per person, 4 liters per second per person. So that's how we have put the values you need for the people part. Now, we also know that it's not only people who pollute the indoor environment. We also have a lot of building materials which have outgassing and also influence the perceived air quality or the odor in the room. So we have also to take that into account. We also earlier took into account if people were smoking or not, but this we do not anymore. So the ventilation rate we are talking about is for rooms without smoking. And for that purpose, we have another table with required airflow for to dilute emissions from buildings. And you can see here we have 3 categories of building. And that's because we want to emphasize the importance of source control to make buildings with materials which has low emissions. And we want to give those who produce those materials and also select them some benefits in that they can reduce the required amount of ventilation. So we have now a value for the people part, and we have a value for the building part. And one of the basic methods, let me just say, we have some criteria where we try to see when can you say you have a low emitting product for low polluted buildings, and when do you have a very low emitting product. At the moment, there's a lot of standard and test methods being discussed for materials, so we will get better information on these emission values for the material, so it should be easier to select what building type we are in. But what we do now is we take the required ventilation rate for a person and have to multiply it by how many people we have in the space, and then we have to add the required ventilation rate for the building part and multiply it by the area. So that will give us the required total ventilation. which is needed in the occupied zone or in the breathing zone. We know there could be difference in systems, so we have to take into account also the ventilation effectiveness, but that's done in another standard, which you will hear about a little later, because that's a system value. And in this standard here, we are mainly dealing with system-independent criteria. So that's how we get to the ventilation rate and what you have to supply with your system. So a table could look like this. If you take a single office, we have a people part, and then depending on what type of building you have, if we have a low pollutant building, we will require totally 1.4 liters per second per square meter. If we just compare here for a single office with the requirements you have in an ASHRAE standard, we see we are at a higher level, but that's also because in Europe we ventilate for people who are not adapted, so people who comes into the room finds it acceptable. We also have now included a way of looking at specific pollutants. If we want to show if, for example, formaldehyde and others, if we don't have too high concentrations, we have this equation, which is the mass balance. You have to look at and verify that you are below given criteria, for example, from ISSO. For the residential buildings, I'm showing here the table which are in the existing standards. This is undergoing at the moment a lot of discussions. We will probably have some values for required exhaust from wet rooms. We will have some requirements based on total air change rate, but we're also discussing have something like similar for non-residential based on people and the building. So what we are, the alternative method for ventilation is that we have a discussion if you should add value. So some countries will like to say, well, we take the maximum of the people or the building component. This is one thing which is being discussed. Also, how can we take into account demand control? Should that be taken into account in the energy calculation? But especially on residential ventilation side, there will probably come some changes within the next months. So the last two things is we also have something for lighting. It's mainly based on other standards. So we show some examples in this document what type of criteria we will use for lighting. Basically, it's the level of illumination, but there could also be other criteria like the color rendering index and so. And finally, we are also dealing with noise. I know I'm showing the tables. The table will be in an annex, so basically, if you want to make a national, you will get a table without any values where you can put in the values, and you don't have to put in all three categories. You can decide in your country we only want to have one category. So here are the criteria we are talking about at the moment for acceptable noise level. You can say the noise do not directly influence the energy calculations or the energy use, but if you make a ventilation system that are too noisy, people will not use it, so we have to guarantee that. The other thing, if you base your ventilation rate on natural ventilation and opening of windows, and you are in a very noisy area, again, that will not be acceptable by people. So we need also to look at the noise part. So we are still discussing some of the revision. There will be some changes from the existing standard, but the basic concept will be the same as in existing standard. Thank you.